So here we're going to look at the cosine rule. And the cosine rule is similar to the sine rule in as much that, again, it helps us sometimes find us unknown angles, and it helps us sometimes find unknown sides within a non-right angled triangle. However, with the cosine rule, we are now no longer looking at information about two pairs. Okay, we're looking at something slightly different. Now, the rule for the cosine rule, the rule says, and it can be a little bit scary, it says that a squared is equal to b squared plus c squared minus 2 times bc times the cosine of a. Now that looks rather daunting, but when we break it down, I find that if you just think about it visually, it can be a little bit easier. So if we take a non-right angled triangle here, and let's say that, so we're looking to find this side length here, okay? So we're looking to find a side length. Maybe it's this side length on this side, okay? And that's what we're trying to find. Well, the pieces of information that I need in order to find that are going to be, I need everything over on this side of the equation. So what do I notice? Well, I notice that this side and this side, they're the remaining two sides. If I'm looking for A, then B and C have to be the other two sides. So we know this one and we know this one. Again, B and C are also located in here, but what you'll notice is that the order doesn't matter. It doesn't matter which one I call B and which one I call C, okay? Because I'm doing the same thing here. So I'm just squaring them, adding them together, and here they're involved next to each other in a multiplication. So it really doesn't matter which one I call B and C. But what we do notice is that the angle of interest is the one that is opposite the side of interest. So that has to be this angle in here, which sits opposite that side that I'm trying to find. So what we see is that we've got these two sides here, side 1 and side 2, enclosing this angle. Okay, so we've got, when we're looking at a non-right angled triangle, how we know if it's the cosine rule that we're wanting to use is we know two sides and we know the angle that is enclosed between them. And then we're looking to find something over on this opposite side here, this side opposite that angle. So that's a situation where we know that we are dealing with the cosine rule. So visually, I find that looking for that situation visually can be a little bit easier than worrying too much about the formula. This is going to make some more sense when we do an example. So we'll come down here and we're going to take on this example here. So we have our non-right angled triangle and we'll say that this bit in here is 30 degrees. We'll say that this is 10 long, this is 11 long, and I've got to try and find what x is here. Well, what do we notice? We notice that first of all, I do not have two pairs, so I can't use the sine rule. I don't have two pairs. I've got a pair here, but I don't have any other pairs in terms of my sides and my angles. So I cannot use the sine rule. So I'm going to have to use the cosine rule. So we see that we're going to need to use the cosine rule. Now, what do I have? Well, I have these two sides which are enclosing an angle here. I know that 10, I know that 11, and I'm creating that angle in there, that 30 degrees, which I know. And I'm looking to try and find the side length that sits opposite that angle, which I know. So I know that visually I'm dealing with that cosine rule situation. Now what we have to do is we have to use the formula. So the formula for the cosine rule says, again, I'll write it down, a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of a. So this a is referring to this side which I'm trying to find. That's my x squared. My b and my c are my other two sides. That's going to be my 10 and my 11. So I square both of those. Again, I subtract two lots of 10 times 11 because that's my b and my c. And you can see again there, it doesn't matter which order I put my 10 and my 11 in. I'm still going to get the same result mathematically. And I'm multiplying by the cosine of the angle, which sits opposite my side, which I'm trying to find. So I'm trying to find this side, and I've got this angle which sits opposite it. That's why the lowercase a and the uppercase a are there. So I put in my 30 degrees into here. Now we can start to solve this equation. If you put all of this bit here into a calculator, you're going to see that x squared is equal to 30.47. Take the square root of both sides and we see that x is 5.52. So hopefully that makes some sense about how we use the cosine rule there. We can do another example now, which is going to be a little bit harder, where we're going to have to find an angle. So again, we're going to have our non-right angled triangle. Let's say that we're trying to find this angle in here. It might be theta, but we know all of our side lengths. We know the 4, the 6, and the 5. Now, I might look to use the sine rule, but I know that I'm going to be in trouble here if I use the sine rule because I've only got one pair. Okay, so there's no other pairs which I know about, so I cannot use the sine rule. So we're going to have to use the cosine rule in this case. Now, what do I do with the cosine rule? Well, I write my formula out. So a squared is equal to b squared plus c squared, take 2 times b times c times the cosine of a. And we know it's going to be the cosine rule because I'm dealing with two sides. The angle enclosed between them is now the angle that I'm trying to find, and I know what the side length opposite that angle is. Okay, so it's just the same situation, but I'm looking for a different piece of information now. So visually, I see there that I'm looking to use the cosine rule. Now, this a squared, remember this b and this c are referring to these two sides which are enclosing my angle. So my a is going to be the one opposite my angle, so that's going to be my 6. So that's my 6 squared. My b and my c are those sides enclosing my angle, so that's my 4 and my 5. Again, I see them popping up in the formula here. And the cosine of capital A, well, that is my theta. That capital A, that's the angle which sits opposite my side lowercase a, that side which sort of sits on its own, away from the two which are enclosing that angle. So now we start to do a little bit of algebra to try and rearrange this equation. So I see that this is 36, 4 squared is 16, 5 squared is 25, so add them together for 41. Subtract 2 times 4 times 5 is going to give me 40 times the cosine of theta. And I can continue to rearrange this. So let's subtract 41 from both sides. I get negative 5 is equal to negative 40 times the cosine of theta. If I divide both sides by 40, I will see that the cosine of theta now is equal to 0.125. Okay, so 1 over 8. And so theta is going to be cosine to the minus 1 of this guy here, which just gives me 83 degrees. So I can work out that if this side length is 4, this side length is 5, and this side length is 6, then this angle in here is 83 degrees. So hopefully that makes some sense about how we use the cosine rule, how we can find an unknown side length and an unknown angle using our cosine rule, okay, and the situations which allow us to use our cosine rule. So we need these two side lengths and this angle which is enclosed between the two.